Actual exam macam mana cikgu? Apa ni? Keshuan apa dia? Keshuan. Then actual exam macam mana cikgu? Actual exam tu lah cikgu kita cuma boleh, cikgu cuma akan cuba habiskan syllabus. Okay, kita akan habiskan syllabus. Kita tengok sempat ke tak kita buat latihan kita buat latihan untuk exam ni. Kalau tak, cikgu akan sediakan latihan dan kamu kena buat lah. Rajin lah. Kena rajin buat latihan lah. Kalau tak, memang susah lah. Memang susah lah nanti. Sebab masa ni tak cukup kan. So, cikgu akan laju je lah. Cikgu akan cuba laju je untuk chapter 5 dan chapter 6 nanti. Cikgu takkan masuk mendalam sangat lah macam cikgu buat untuk chapter 2. Hari tu cikgu tersilap lah. Cikgu banyak bagi example untuk chapter 2 sehingga kan cikgu terlepas pandang exam kamu bulan 2 rupanya kan. So dia dah drag masa sikit dia dah drag masa supaya sepatutnya cikgu dah masuk chapter 3, chapter 4, tapi kita drag chapter 2 banyak sangat. Tapi cikgu akan bagi kamu latihan kamu terpaksa buat sendirilah buat sendiri latihan tu. Kalau boleh rajin-rajin lah buat latihan. Carilah soalan kat mana-mana pun yang ada itu akan bantulah. Alright, so this is complex numbers. Cikgu dah go through sebenarnya chapter 4 ni sampai habis dengan kamu notes dia. Cuma hari ni kita akan buat latihan supaya lagi mantap lah kamu punya complex numbers. Okay, so cikgu akan tunjuk beberapa contoh. Alright, based on this notes. Notes ni cikgu dapat daripada ketua pemeriksa exam ST. Cikgu ada masuk kelas dia dan cikgu rasa sangat membantulah untuk notes ni. So let's try to do some of these examples. So introduction, alright. Ni introduction lah mathematician Girolamo Cardano is first to known have introduced complex numbers dia ni Italian mathematician. Okay, in the 16th century sebenarnya. Right. So for complex numbers, like what you already know, that it consists of imaginary numbers and real numbers. Okay. Now, what are imaginary numbers? Imaginary numbers numbers, okay, that are not real numbers that are not real numbers. For example, plus minus, square root, minus 1. Okay, so since square root minus 1 is equals to square root 1 times square root minus 1, then this is equals to 1 times I, which is I. Okay, so we denote square root minus 1 as I, which is an imaginary number. Okay, square root minus 1 is I. Right. A set of numbers whose square are negative real numbers are known as imaginary numbers. For example, square root minus 1, square root minus 5, square root minus 18, square root minus 36, or any numbers with a minus sign are all imaginary numbers. So you can say that a general member of this set is square root of minus n square. All right, minus n square. Where square root minus n square is equals to square root n square times minus 1. All right, so you have square root n square times this minus 1, square root minus 1. This is I. Okay, so this becomes ni. Okay, ni. Okay, let's try to express some of these numbers in n and I. So there's a square root of minus 4. Okay, square root of minus 4. If we write this down, all right, okay, square root of minus 4. So this is just square root 4 times minus 1. Okay, 4 times minus 1. So this is also equals to square root of 4 times square root of minus 1. So this is just 2i. Okay. So for now, you should be able to change, okay, for any imaginary numbers into in form of I. Okay, in form of I. And the constant, okay, the constant must be in a form of n square. Okay, square root n square. Square n square. All right. So let's look at square root of uh, 5. Square root 5. Ini bukan n square lah. But if you don't have in the form of n square, okay, you just can simply, all right, square root minus 5. Okay, this is just equals to square root 5 times minus 1. All right. In bracket minus 1. Right. So this is, you can separate these two, comes square root 5 times square root minus 1. So this is just square root 5i. Okay. Right. So you can do the cikgu dah bagi notes pada kamu, boleh tengok pada notes tu, dan cuba buat semua latihan dalam notes ni lah. Cikgu I will not go through all the questions. I will choose some of the examples, okay, and let you to do the rest. Kalau ada soalan nanti tanya je, nanti cikgu cuba jawab lah, kan. Sebab cikgu tak nak bazir sangat masa. Right. Next is doing algebraic operation on imaginary numbers. Okay, imaginary numbers can be added to and subtracted from other imaginary numbers. So imaginary numbers and imaginary numbers, you can do operation on these the coefficient of the imaginary numbers. For example, if you have ai plus minus bi, so this is just a plus minus b, and then you have I. Okay. The product quotient of two imaginary numbers is a real number. Okay. So if you multiply, okay, two imaginary numbers, so this becomes ab I square. Okay, I square. Since you know that I is square root minus 1, so I square is minus 1. Okay, the square root disappears. So it becomes minus AB. Minus AB. Now, if you divide two imaginary numbers, okay, AI divided by BI, the I's will cancel. Okay, I to boleh cancel each other. So you are left with A divided by B. If you have a reciprocal of imaginary number, which is 1 over I, so this is equals to minus I, where you do the cancellation of I. Okay, biasanya kita tak ada I dekat denominator macam cikgu sebut tu lah. So kita akan darab dengan I over I. Alright, I over I. So it becomes I over I square. So this becomes I over minus 1. So it becomes minus I. Right, there's a point to note. The power of I equals to square root of minus 1. So I square is minus 1. But if you have higher powers, okay, for example, I cube, right? I cube is I times I square, which is minus I. I to the 4 is just minus 1 times minus 1. So this is equals to 1, right? And then I to the 5 is I to the 4 times I, which is I. Okay. So I to the power of n, okay, you can say that I to the power of n can take either one of the four values, minus I minus 1 or 1. Okay, ni je. Only these four values are the values for power of I. You can either get minus 1, minus I, 1 or I. Okay, now let's look at some of the following. Okay, so the value of the following 2i plus 3i. Okay, so if you add these two, gives you 5i. Okay, you can also subtract a 5i minus 7i. This will give you minus 2i and so on. All right, this is multiply, so you can multiply 3 times 2i will give you 6i times 5i. This is negative 30. Alright, negative 30. This will give you a real number. Real number. Okay, and so on. Nanti kamu buat lah. Kamu boleh buat lah. Okay, terus. Okay, identify the real and imaginary parts of complex numbers. Alright, so now we are introducing the complex numbers. A complex number is a number that can express in the form of a plus bi, where a and b are real number and I is called the imaginary unit, where I square equals to minus I, macam tadi kita bincang tadi. Now, a complex number usually denoted by Z or W, where Z and W are all complex numbers. Complex numbers I see. Z is equals to a plus bi, and this is also known as the Cartesian form. Okay, kalau soalan minta, okay, change the following into Cartesian form. So you need to know that you need to change it into this form, a plus bi. A plus bi. A is known as real part and b is known as the imaginary part of the complex numbers. Okay, so we can rewrite it as RE. RE is real, real of Z is A, and IM is the notion for imaginary number. Okay, IM Z is B. All right. So if A equals to 0, if A equals 0, so Z is purely imaginary number. Purely imaginary number kalau A is 0. If b equals to 0, then z is a real number. Real number A. B0 tak ada imaginary part. So dia tinggal real number saja. So for example of a complex number is 2 plus 3i and so on. Okay. If you have just a real number 5, okay, this means that the imaginary number is 0. If you have 7i, so then the real part is 0. Right, now a set of complex number is denoted by C. C, this complex number. And real numbers are all subset of this complex number. Okay, this complex number. Meaning that real numbers are a part of the complex numbers lah. Sebab complex numbers ada dua bahagian. One is the real part, one is the imaginary part. Right. For example, here state the real part and imaginary part of the following complex number. So you need to know that for this complex number, you can you are able to identify which is the real part, which is the imaginary part. Okay, so for example, if you have 4, okay, z equals to 4 plus 3i. So now the real part, you can rewrite it as rez equals to 4. Imaginary part is imz equals to 3. Okay, so this is one example that is very useful later, right? Where you know how to differentiate between real and imaginary parts. All right. So let's look at D. W is 3i. So if W is 3i, meaning that your real part is 0. All right. Real part of z, of z equals to 0. Imaginary part of no, not z, w, sorry. So real part of w, imaginary part of w is 3. Okay, so the real part for w here does not exist, 0 dia tak ada, but there's only the imaginary part. Okay, imaginary part, which is 3. Okay, now we'll be talking about conjugate. Okay, conjugate of a complex number. This is very important, where for conjugate of complex numbers, it's very useful to when you do division. Okay, division of two complex numbers, and also when you want to simplify your complex numbers, given if the complex number is in a fraction. So kalau jumpa complex number yang fraction, okay, it's better if you can uh, do the complex conjugate, complex conjugate for that complex number. Yeah.
Wow. 2 by 9, 9,
Okay. All right. So the conjugate of a complex number, if z is a plus bi, then a minus bi is known as the conjugate for z. Okay, and is denoted by z star or z bar. All right. If z equals to a plus minus bi, then the complex conjugate is the opposite sign, opposite sign for z. A more universal way to see conjugate as a replacement of I by minus I. Okay, so you can also denote it as replacing I, okay, this positive I as negative I. If you have Z conjugate and you conjugate that Z conjugate, it gives you Z. Okay? Okay, I think by now you can rewrite the conjugate pair or conjugate of this complex number. Kita dah cuba buat ada kita cuba buat ada kita cuba buat waktu waktu kelas hari tu. Alright, I'll just show you one. Right, if you have z equals to 2 plus 3i, okay, so the conjugate for z is, or z star is just 2 minus 3i. Okay, or if let's look at e, all right, for 7 minus 3i. Okay, if w equals to 7 minus 3i, so w star is just 7 plus 3i. Okay. The sign changes. Right. Okay, so right, so let's continue. Right, now we want to perform elementary operations on two complex numbers expressed in Cartesian form. Okay, so we can do addition and subtraction for two complex numbers. For example, if you add two complex numbers or subtract two complex numbers, you can do so for real numbers with real numbers, imaginary numbers with imaginary numbers. Okay, tak boleh nak share, tak boleh nak do operation on real and imaginary. Tapi real dengan real sahaja boleh, imaginary dengan imaginary sahaja yang boleh. Okay. If you add a complex number with its complex conjugate, all right, for example, a plus bi plus a minus bi, this will give you only real numbers. Okay, real numbers. And if you do subtraction of a complex number with its complex conjugate, it will only give you imaginary numbers. Okay, tengok dia dapat imaginary numbers saja. Now, if you multiply, okay, multiply a constant to the complex number, the constant will multiply to both real numbers and imaginary numbers. Okay, k itu darab dengan real number a and imaginary number b. Now, if you multiply two complex numbers, okay, two complex numbers, you have to multiply to both real and imaginary parts. Okay, dia akan kembang lah untuk real part and imaginary part pun sama. If you multiply complex number with its complex conjugate, it will give you a real number, which is a square plus b square. So ini kamu tak perlu nak kalau kamu darab biasanya kita darab untuk pemudahkan fraction to simplify our fraction. So we multiply with its complex conjugate, it will give you a real number, which is just a square plus b square. Tak perlu nak kembangkan, itu tak apa. So these two steps kamu tak perlu nak buat, kamu terus buat a square plus b square, right? Because this is proven true to be true. Okay, try to simplify the following. Cikgu rasa kamu boleh dah buat ini. Cikgu tunjuk satu contoh cukup dah ke So 2 plus 7i, alright, plus 3 minus 4i. right? So what you need to do is to add uh, the real parts together and the imaginary parts together. So kalau senang kamu terus buat asingkan and 7i. Here is 3 and then minus 4i. Alright. So you add. Kalau nak kalau ni untuk pelajar yang lemah lah yang lemah, you can add like the following. Okay, imaginary will add only with imaginary. Real will only add with real numbers. Okay, so this is part for real numbers. This is part for imaginary numbers. So 7 minus 4 will give you 3i, and then here you have 5. Okay, so your conclusion is will give you 5 plus 3i. Okay. Okay, next is okay, I think the rest you can do. Express the following in the form of x plus iy. Okay, so if you multiply, so you have to multiply to the real and imaginary part. Okay, let's try to do one example here. 2 plus I. So you have 2 plus I multiply with 3 minus 2i. Okay, so if you multiply here, you get 6. Okay, minus 4i. Okay, here you get plus 3i, and then here is minus 2i square, right? So you can bring all the real numbers to the front. So this is 6 minus 2. I square is just minus 1. Okay, and then here is minus 4i plus 3i. Okay, so this is 6 plus 2, which is 8. And then here is minus I. Alright, so it's just 8 minus I. Okay, I think the rest you can do. Quite simple. And then you have division of complex numbers. Complex numbers can be divided by a constant, right? So if you divide a plus bi with k, so you can separate the constant to a plus k plus b over ki, right? So this is very useful when we do fractions. When we multiply your fraction, complex numbers with its complex conjugate, you get a constant, at the denominator here. Okay, for example, like k lah. So what you need to do is you can separate the real part and the imaginary part. Right. Now, division of two complex numbers, direct division of two complex numbers cannot be carried out because the denominator is made of two independent terms. So, to divide two complex numbers as z1 over z2, you need to multiply the denominator with its conjugate. So, by multiplying with the conjugate, this means that we are rationalizing the denominator. Maksudnya lah, rationalizing denominator. So we multiply the denominator here with its complex conjugate. Okay, so atas bawah pun kita multiply dengan conjugate of denominator here. So we will end up with a constant. Kita akan dapat constant dekat bahagian bawah ni. Alright, so this constant later you can separate. You can separate into real part and imaginary part. Right. Okay, let's look at some examples. Yang ni yang cikgu nak tekankan lah. Ini yang penting lah untuk complex numbers. Okay, let's look at some examples here. Look at example A, 1A. Alright, so for example 1A, alright, so you have 2 plus 3i, okay, over 1 minus 2i. Okay. So this is equals to, right, 2 plus 3i over 1 minus 2i multiply, we'll multiply with the complex conjugate for the denominator, which is 1 plus 2i. Okay, plus 2i. So this is something that you need to know of. Alright, yang students kadang-kadang buat salah sebab dia tak tukar simbol ni. Alright, if you have a negative, okay, the complex conjugate is a positive sign, right? So then what you do is you can multiply, right, 2 plus 3i with 1 plus 2i, and then the denominator is just 1 minus 2i, or we already know that if you multiply z with its complex conjugate, it's just 1 square plus b square, 2 square. Okay, right, a square plus b square, right? So this is just, okay, 2 plus 4i plus 3i minus 6 divided by 5. Okay, so at the denominator here you will get a constant. So this is just minus 4 plus 7i over 5. Now this constant you can separate into a real form, okay, or real part, which is minus 4 over 5, and then add with the imaginary part, which is 7 over 5i. Okay. Right. So another example, okay, if you look at B, so this is 1 plus square root 3i divided by 1 minus square root 5i, right? So if we multiply, right, we want to rationalize our denominator, we multiply it with its complex conjugate, which is 1 plus square root 5i, okay, over 1 plus square root 5i, right? So this is just equal to 1 plus square root 3i multiply with 1 plus square root 5i divided by 1 square plus square root 5 square. Okay. So this is equals to 1 plus square root 5i plus square root 3i minus square root 15 over 6. Okay, so now we can simplify to be 1 minus, sorry, oh, becomes 1 minus square root 15 divided by 6 plus square root 5 plus square root 3 over 6 pi. Alright, sebab dia dalam square root so dia jadi 1 minus square root 15 plus square root 5 plus square root 3 over 3 over 6. So you can have it into this form, or you can change it into decimal lah. Right, change it into decimal. Sebab square root ni dalam bentuk decimal. Ni exact form, kamu nak tukar jadi decimal lah. Habis. Nak lagi? Right. Okay. Okay. Right, any questions? Ada soalan tak? Tak ada So okay, cikgu continue lagi Alright, I think the rest you can do. Okay. Cikgu nak teruskan ke question number 2. Okay, given that z equals to 2 minus I and w equals to minus 1 plus 3i and v equals to 1 over z minus 1 over w. Find the real part and imaginary part of v conjugate. Okay? Conjugate of v. So first you need to know what v is, okay, and then you can change it to conjugate of v. So if z equals to 2 minus I and w equals to minus 1 plus 3i. Okay. So 1 over z, 1 over 2 minus I. Okay. Now let's rationalize our denominator here. We multiply with 2 plus I over 2 plus I. So this will give you 2 plus I over 2 square plus 1 square, which is 2 plus I over 5. So here this is 2 over 5 plus 1 over 5i. Okay, so this is 1 over z. 1 over w is 1 over minus 1 plus 3i. So if you rationalize our denominator, we get minus 1 minus 3i over minus 1 minus 3i. Okay, so this is just minus 1 minus 3i over minus 1 square plus minus 3 square. So this is equals to minus 1 minus 3i over 9 plus 1 is 10. Okay. Ada soalan? Masuk. Alright, so this this can become minus 1 over 10 minus 3 over 10i. Okay, so now we can find v. V is just 1 over z. One over z minus and 1 over z minus 1 over w. Okay, so this is just 2 over 5 plus 1 over 5i minus 1 over 10 minus 3 over 10i. So this will give you 1 over 2 plus 1 over 2i. Okay, we do the fraction, you get 1 over 2 plus 1 over 2i. Now v conjugate is just the changes of sign for I, which is half minus half I. Right, done. Okay.
Cikgu,
Yes.
cikgu nak tanya boleh panjangkan masa tak? Sebab macam boleh sambung lagi.
Boleh. Cikgu ingat nak sambung lagi lah. Boleh je. Kalau kamu okey, cikgu okey je sebab hujan tak pergi mana pun kan.
Orang lain boleh tak?
Siapa? Yang lain boleh tak? Yang lain okey tak?
lain.
Kalau tak boleh pun cikgu record. Kamu boleh on off je. Tak ada masalah. Cikgu akan cuba habiskan sampai pukul 12 lah. Pukul 12 Okay, cikgu tambah lagi 1 jam lah. Right? Okay. Alright. Okay, so this is a real part and imaginary part of V. Okay, let's look at question number 4. In question number 3 ni cikgu rasa kamu boleh buat lah. Reciprocal is just 1 over z. 1 over z. So you can then simplify for 1 over z macam cikgu buat tadi. And you can solve for these two. Okay, cikgu nak tunjuk ni. Number 4 ni agak susah sikit lah. Alright, if w and z are two complex numbers and w is not equal to 0, prove that w over z conjugate equals to w conjugate over z conjugate. Okay, if ini pernah keluar soalan dalam exam pernah keluar dalam exam and students tak tahu nak buat macam mana. So if you get question like this, okay, without stating the okay. All right, without the question stating any form of complex number, all right, what you need to do is okay. Okay, what you need to do is you need to know that z, okay, z is always in the form of a plus bi, okay, form the a plus bi. And you can also have, if you're given, like for example here ada dua complex number w and z so the other complex number, okay, you can also denote it as x plus yi, okay. Ini yang pelajar tak tahu, okay, students don't know. Okay, students don't know. When students don't know that z equals to a plus bi and w is x plus yi, they tend to not answer this type of question. Sedangkan dia taklah apa nak susah, right? So if we know that z equals to a plus bi and w equals to x plus yi, then you can simply do this question So you want w over z, w over z. Okay, w over z is equals to a plus bi over x plus yi. Now we rationalize, okay, we rationalize our denominator, okay, by multiplying with the conjugate for this denominator, which is x minus yi over x minus yi. Okay. So everything dia tak ada nilai lah, sebab dalam question dia tak ada bagi apa itu dia punya coefficient, right? So we just put it into a, b and xy lah, right? Tak ada value lah, tak ada number lah. So this is just ax, okay, minus ayi plus bx I plus by, okay, over, okay, this is x square plus y square. Okay. Macam tadi lah, macam kita buat sebelum ni kan. Alright. So this is w over z. Okay. So we can then separate the real part and imaginary part. Okay, and see. This is ax plus by over x square plus y square, and plus plus bx minus ay over x square plus y square I. Okay. So this is w over z. Okay, w over z. You can have it as plus. Okay, plus here, right? You take bx minus ay, so it becomes a positive value here. But for its conjugate, all right, the conjugate for this is just ax plus by over x square plus y square minus bx minus ay over x square plus y square I. Kat situ jadi tukar sign dekat sini. Right. So when we do this, okay, so this now becomes ax, okay, plus by minus bxi plus ayi over x square plus y square. Okay. So if we then factorize this, okay, we factorize it back, becomes a minus bi x plus yi over x plus yi x minus yi. Okay, so the x plus yi both can cancel, so you are left with a minus bi over x minus yi, which is w conjugate over z conjugate. Okay, sure. Right. So the difficult part is here, right, where you need to know how to factorize. Okay, if you do this correctly, then you get your answer lah, right, to show that w over z conjugate is just the conjugate of w over conjugate of z. Ada soalan tak? Okay. Right, let's continue. Okay, for this, you need to find the real number, the values of a and b. So this you just simplify, or you solve for this fraction to get in the form of a plus b, and you can get the value of a and b. Okay, let's look at this. Let's look at this question number 6, where z equals to x plus ix. Okay, where x is a non-zero real number. Show that z minus z conjugate is I z plus z conjugate. Ini ini cikgu rasa pelajar memang kalau dapat soalan ni memang tak buat lah. Alright. Question number 6. Page there. Alright, so if z equals to x plus ix, x is all real numbers, we need to show that z minus z conjugate is equals to I z plus z conjugate. Okay. So let's, you can begin from the left hand side or the right hand side, any left hand side or right hand side. Tak ada masalah kamu nak mula daripada mana satu. if you start from the left hand side, you need to prove that it's equals to the right hand side. If you start from the right hand side, you can then prove that it's the same as the left hand side, vice versa lah, right? So this type of question, okay, I think it's the first time you've seen this type of question. So kita cuba lah cikgu expose kamu pada soalan-soalan macam ni lah yang tak pernah jumpa lagi lah sebelum ni, right? Okay, so this is just x plus ix minus, I'll start with the left hand side and prove it's the same as the right hand side, right? So plus ix, okay. So this is equal to x minus x and then yeah. So this is just x plus ix minus ni x conjugate, sorry. X conjugate ada minus sign, ni positif, this is negative sebab z conjugate equals to x minus ix, okay. So this is minus x plus ix, okay. Now we want I. So this is I multiply with x plus ix minus x plus ix, okay. Oh, sikit. Silap. Now, if we factorize out, okay, factorize out, sini macam ni They factorize out I, okay, factorize out I. So you should know, untuk case yang ni lah, x is just I minus ix. Okay. Ini yang student tak tahu. X equals to I multiply with minus ix. Okay. Kalau kita darab balik, so this is minus I square x. So this is minus 1x. So it becomes x. Alright. So to factorize out I, okay, factorize out I. So this is just I minus ix, okay, for x ni akan jadi minus ix. This ix becomes plus x, and then here is minus ix plus ix becomes x. Okay, so this is just I minus ix plus x plus ix plus x. Good. So this is I. This is x minus ix plus x plus ix. So this is just I z conjugate plus z. Sure. Okay. So ini yang nak kena highlightkan lah, right? Ini students tak tahu lah, students don't know. Right, students don't know this. So when you know this, okay, you can factorize out I. Factorize out I, and it will give you minus ix. Minus. Another thing is, okay, if you have 1 over z conjugate, okay, so this is just 1 over x minus ix. Okay. So we can right, for this we can biasanya kita rationalizekan denominator multiply dengan x plus ix over x plus ix Tapi untuk kali ni, alright, kita nak provekan dia, alright, kita kena bergantung pada soalan juga sebenarnya, kita kena bergantung pada soalan juga. Okay, so the question asks, for 1 over z conjugate equals to I 1 over z. Alright, kita nak tukar jadi macam ni. So kalau kita multiply, alright, dengan complex conjugate dia, alright, kita susah sikit nak dapat dalam bentuk ni, right? So the best way is for us to factorize, factorize I. Factorize I. Okay, we multiply with I over I. Okay. So we get I over, here is xi minus I square x. Okay, so this becomes I over x plus xi, which is I 1 over z. Okay, which is what you want here. Sure. Okay, so bergantung kepada situasi lah, bergantung pada soalan. Tak semestinya when you find a reciprocal of z, okay, you need to always multiply with its conjugate, right? Depending on the question, apa yang question nak. Kalau question tu biasa yang standardnya, kamu kena biasanya standard kita multiply dengan conjugate dia. But for this question here, the tricky question, okay, the simplest is just you multiply with I, right? Multiply with I, you will get in the form of z, z, bukan conjugate z. Okay, so cikgu nak kamu berhati-hatilah kan. For complex numbers ni, tak semestinya kamu kena multiply, asyik-asyik semua kena multiply dengan conjugate pair. Or dia punya conjugate dia lah. Kadang-kadang just multiply dengan I pun dah dapat jawapan. Alright. Okay, let's look at question number 8. Right. Question number 8, you have a power. complex number with a power, right? Where n is an integer. Show that z equals to 0. Okay. Okay. Apa tadi? Question number 8 Right, so you have 2 plus 3i to the power of 4n plus 2 plus 3 minus 2i to the power of 4n plus 2. Right. Okay, so you can see here, all right, there's a pattern, right? If we put 2 plus 3i to the power of 4n plus 2, and then plus, here you have 2 and 3, but um, it's in a different form lah, different form. Um, uh, for the real part is 3, imaginary part is 2. Now we can switch. We can switch the imaginary and real parts, okay, by doing the same as what we did for the previous question. So if you have, for example, x, okay, so this is just minus I times ix, okay. So if you have 3, so this is just minus I times I3, okay, will give you 3. So this will give you an imaginary part for 3, right? So this you can change it to minus I, all right? So this becomes I3 plus okay, I3 plus 2, okay, because this I, all right, you factorize as minus I, okay, and then this is to the power of 4n plus 2. Oh, cikgu esok pun dah tak limat lah. Alamak ni. So hari ni dah kena habiskan lah. 3 hari straight sampai Rabu. Okey. Alamak. Okay, so this now you can see that it's the same. So this becomes 2 plus 3i to the power of 4n plus 2 plus, okay, so this is a standalone minus I 4n plus 2 multiply with 2 plus 3i 4n plus 2. Okay, so kita dah boleh buat ni, I ni stand alone dia sendirilah. And then 2 plus 3i sama dengan ini. Okay. So this is just 2 plus 3i 4n plus 2 plus, okay, so this you can separate, so this becomes minus I to the power of 4n multiply with minus I to the power of 2. So this is 2 plus 3i 4n plus 2. Now, n, we can put in any value, okay, 1, 2, 3, 4, okay. So if for minus I to the power of 4, this is minus I square minus I square. So you know that minus I minus I uh, I is square root minus 1. Minus I is minus square root minus 1. So minus I square is minus 1. Betul eh? Minus I square multiply with minus I square. This is equal to, so minus I to the 4 is 1. Alright. So this is a multiple of 4. So kalau letak 2 ke 3 ke 4 ke sini masih lagi 1 lah. Still 1, right? So this is just 2 plus 3i 4n plus 2 plus this is 1. This is minus 1. This is 2 plus 3i 4n plus 2. So this is just this minus this. Okay, so you get 2 plus 3i 4n plus 2 minus 2 plus 3i 4n plus 2, which is equals to 0. Okay, so ada banyak benda lah yang dalam ni yang kamu kena tahu. Alright, for example here, if you have x, okay, you can change this real number into a complex number, right, by just factorizing minus I. Okay, factorizing minus I. And then in this case, for minus I to the higher power, all right, you can either get minus 1, 1, I or minus I lah. Ada 4 lah. Ada 4 situasi lah. Sebab nanti kamu dapat minus 1, 1, I or minus I. All right. This is another example where this question has come out in the exam. Pernah keluar daripada exam and students tend to find this very difficult to answer. Okay, so kita cuba tengok jawab soalan nombor 9 nombor 9. Okay, so if z plus 1 over z equals to minus 1, right? Then you want z cube. Okay, z cube to show z cube equals to 1. I have to show that z cube equals to 1. And z to the power of 8 plus z to the power of 4 equals to minus 1. So, what can we do? All right, you are given this situation, all right, this condition. So for here, you can just multiply. You can just multiply and simplify this equation to become z squared plus 1 equals to minus z. Right? So you have z squared equals to minus z minus 1. Now what we want is for you to have z cubed. So z cubed, all right, equals to it's just z multiply with z squared equals to z multiply with minus z minus 1. Okay, we introduce the z okay, into this equation. So this will give you z cubed equals to minus z squared minus z. Now you know that z squared, okay, z squared is this. So z cubed equals to minus z minus 1 minus z. So z cubed equals to z plus 1 minus z. Macam mana cerita di sini? Okay, plus 1 minus z. So z cubed equals to 1 should. Right. So we know that z cubed equals to 1. Now we want z to the 4 and z to the 8. Okay. So z to the 4 is just z. Okay, if you multiply z to both sides, you get z to the 4, which is z. And if we square z to the 4, we get, for both sides, square both sides, we get z to the 8 equals to z squared. Which is z squared is this. So z to the 8 is actually minus z minus 1. Hence, you can say that z to the 8 plus z to the 4 is just minus z minus 1 plus z. Which is minus 1. Sure. All right. So this is another skill that you need to know for complex number, complex numbers. Okay. Kadang-kadang students bila dia tengok benda macam ni, dia terus tak berminat untuk jawab. Okay, sebab dia rasa benda ni susah. Tapi sebenarnya dia senang. Okay, when you know how to do it. When you know how to do it, it becomes much simpler lah. Alright. Okay, ada soalan tak? Before we move on. Alright, next. Okay, ada soalan. Cikgu biasanya, berapa markah untuk ni? Okay, untuk yang ini biasanya cikgu tengok untuk yang ini 1, 2, 3, 4. Biasanya 4 markah. 4 to 6 marks lah can get. Tapi biasanya 4 marks lah. 4 marks untuk soalan macam ni. 4 marks kita tunjuk 4 marks. Okay, so one, right, is for you to get this, right? One. Okay, and this is 1 mark. Okay. Right, and then for this is for you to multiply ni. This is 1 mark, and then here is another mark. Okay, dekat sini ini, right? And then dekat sini ataupun dekat sini, either this lah, right? This or this, where you know how to substitute. Kat sini lah, dua ni ataupun dua ni, dua ni, right? Yang lain semua tak ada markah lah, dia ada hanyalah dia punya jalan kerja je. Okay, so these two are the skill that you need to know. Right? Okay. Okay, let's move on to next. Okay, next question is this. Given that W equals to P plus 4I over 1 plus IP, where P is a real number. If W is a real number, find possible values of P. Kena faham W is a real number. Okay, W is a real number, which means that the imaginary number is 0. Right? Right. So this type of question selalu keluar dalam exam macam ni So P plus 4I over 1 plus IP. So this is a real number. So real of W exists, right? But imaginary number for W is equals to 0, right? Does not exist. Sebab dia real number, real number. Bila dia kata real number dia exist tapi imaginary number dia 0. Walaupun kat sini ada imaginary, tapi dia equals for this W, the imaginary part is 0. Okay. Bila imaginary part equals to 0, baru kita boleh nak solve for P. Okay, kita tengok So you can, if you rationalize our denominator here, so W equals to P plus 4I over 1 plus IP multiply with 1 minus IP over 1 minus IP. So this will give you P okay, P plus 4P plus 4I minus IP square. Okay. And then this is over 1 square plus P square. Right. So if we simplify this, okay, divide this into real and imaginary part. So this we get P plus 4P over 1 plus P square plus 4 minus P square I over 1 plus P square. Okay, So this is the real part which I mentioned, real part. This is real of W, and this is imaginary of W. Okay. Now since W is real number, hence you can say that I m W, imaginary of W equals to 0. So you can say that 4 minus p square over 1 plus p square equals to 0. Right? So you have 4 minus p square equals to 0. P equals to 4. P square equals to 4. P equals to plus minus 2. Right? So you can solve for P equals to 2 or P equals to minus 2. N. And right. So ini yang selalu keluar lah exam dia tanya if the complex number is only a real number or only imaginary number. Alright. Kalau only real number, only imaginary number, then kamu kena guna salah satu saja. Guna salah satu, sama ada guna real number or guna imaginary number. Right, untuk solve. Okay. Very penting, very crucial lah itu very crucial. Alright. Okay, next. Okay. Kita dah masuk sini. Use the conditions for the equality of two complex numbers. Okay. Kalau kamu dapat macam ni, macam soalan tadilah, macam soalan tadilah, dia minta kamu compare to solve and find any value A or B. You can equate with real part with real part, imaginary part with imaginary part. Okay. For example, kita dengar value, find the values of A and B if minus A plus BI equals to this complex number multiplied with another complex number. Okay. So kita tengok ini. Three plus 4i and minus 2 minus 3. So this is minus A plus BIN. Okay. Alright, so we can solve for this these two complex numbers, and then we can compare the real part and imaginary part to get the values of A and B. Macam ni lah, macam kita buat yang atas ni. Alright, you should know that you can separate the complex numbers into two parts, real parts and imaginary parts. Now, if it's real number, so imaginary part will be 0 and you can solve. If it's imaginary number, then the real part is 0, so you can solve for P using the real part. Okay. Same goes for here. You can find values for A and B by comparing the real part and imaginary part. Okay, so here if we can solve for this, give you minus 6 minus 9i minus 8i minus 12i square. So this is 6 minus 17i. So this is minus A plus BI. So you can compare the real part and imaginary part. So A is minus 6, right? and B is minus 17. Okay, so easy now. I would like to go straight to difficult questions, but ini semua cikgu rasa kamu boleh buat lah, dia straightforward saja. Cikgu nak pergi yang lebih susah sikit, which is this one here. Alright, so given that 9 plus 2i z, okay, plus 7w equals to 52 plus 2i, find z and w in the following cases. If z and w are real numbers, right, and if z and w are complex numbers, such that w is conjugate of z. Okay, soalan ni susah lah, soalan ni agak susah. Okay, so how do we do this question? Okay, so yes. Okay, so we have 9 plus 2i, and then this multiply with z plus 7w equals to 52 plus 2i. All right. So we if we let kita boleh terus solve kat sini. Ini kita multiply jadi 9z plus 2zi plus 7w equals to 52 plus 2i. So kalau dua-dua real number tak ada masalah lah So 9z plus 7w plus 2zi equals to 52 plus 2i. Okay, this I rearrange so this is real part. This is the imaginary part lah. Right. So we can compare real parts and imaginary parts. So you can compare the imaginary parts. So you have 2z equals to 2, z equals to 1. So you have 9 times 1 plus 7w equals to 52. So 7w equals to 43. W equals to 43 over 7. Tak ada masalah lah untuk real Kalau dua-dua if Z and W are real numbers. Okay. Now ni yang datang susah ni. If Z and W are complex numbers. Right, complex numbers. So you have to do what I've mentioned earlier. Z, you know that is A plus BI. Right? Or you can put it as X and Y lah. Contoh cikgu tulis dah X plus Y. Okay. So this is in the form of complex numbers. Okay, if Z is a complex number, right? And the given kat situ W is Z conjugate, right? So X minus YI. Okay, kena baca soalan betul-betul, right? And then jadi tak susah. Tak susah. Kalau tak dia jadi susah lah sebab tak faham nak buat macam mana. Okay, so it becomes 9. Okay, masukkan balik dalam ini lah. Dalam ini. This one. Real and imaginary ni. And then you can compare lah. Okay. So you get 9 Z is X plus YI plus 7 X minus YI plus 2 Z. Z is X plus YI I. equals to 52 plus 2i. Okay. So let's expand this, becomes 9x plus 9yi plus 7x minus 7yi plus 2xi plus 2yi square equals to 52 plus 2i. Okay, so here you have 9x plus 7x minus 2y. Ini jadi minus Ni I square kan, I square jadi minus 1. And then you have plus 9yi minus 7yi plus 2xi equals to 52 plus 2i. Okay, so this is the real part and this is the imaginary part. So you have 16x minus 2y equals to 52 and 2y plus 2x equals to 2. So you have y plus x equals to 1 and here you have 8x minus y equals to 26. So if we solve for this, you can get so this solve you get y equals 1 minus x. So 8x minus 1 minus x equals to 26. 8x plus x minus 1 equals to 26. 9x equals to 27. X equals to 3. Y equals to minus 2. Okay. So at the end, you can say that z equals to 3 minus 2i and w equals to 3 plus 2i. Okay, ada soalan? Setakat ni. Okay, this is I guess the hardest, quite hard question for comparing, finding complex numbers for when you equate two complex numbers. Ada satu lagi yang cikgu nak tunjuk sebelum kita stop. Okay. Given, question number 10. Given square root 15 minus 8i equals to a plus bi, find the values of a and b. Okay, a and b. Ini pun agak susah jugalah. Right? All right, now so you have square root of 15 minus 8i equals to a plus bi. Okay. So what can we do here? You can square both sides. Square both sides. Right. So you have 15 minus 8i equals to a plus bi squared, right? So this becomes 15 minus 8i equals to a squared plus b squared minus 2abi, right? Okay, so now we can compare. So this is the real part. This is the imaginary part. Right. So you get a square plus b square equals to 15, and minus 2ab equals to minus 8.
Yes.
Sorry.
Asyik. Sabu.
Sekejap. A plus bi.
Ajak bertis. Aku. Aku orang mana? Ada sedikit pokok. Betul.
Oh, sorry, sekejap. Dia silap. Sekejap, cerita.
Hah?
Okey, okay. Soalan dia salah.
Cik.
Soalan dia, kamu tolong betulkan Soalan dia ni A minus BI
Yo.
Betul kan? Sekejap. Oh. Betul lah. Sekejap, betul. A plus BI. Ni BI square. So dia jadi negatif. I square ni jadikan dia negatif. Sorry cikgu salah. Okay. Cikgu yang salah kat sini. So betul lah jawapan soalan dia betul, A plus BI. Cikgu yang salah dekat sini. Alright, so dia BI square. Alright, okay. Now dah betul. Alright. So 2AB equals to minus 8. Okay. Alright, so you get B equals to minus 4 over A. 4 over A. So this you can substitute in. So a square minus 4 over a square equals to 15. So you get a square minus 16 over a square equals to 15. So you get a to the 4 minus 15 a square minus 16 equals to 0. So factorizing this, so you get a square minus 15, minus 16, a square plus 1. So 0. Okay, so we can factorize this and then we can equate to 0. So you get a square equals to 16 and a square equals to minus 1. So now a square, okay, a square, you should know a square is always positive. Right? A square is always positive. So you can note here that rejected and a square is always bigger than 0. So you cannot get a square to be minus 1. So you only accept a square equals to 16, a equals to plus minus 4. Right? Because A and B, right? A and B, syarat dia, A and B, dua ni must be real number. Alright, must be real number. Dia ni coefficient dia ni, coefficient dia. I ni yang buat jadi kompleks. Tapi A dengan B ni mesti real numbers. So dia tak boleh jadi negative 1. Cannot. Cannot be negative 1. Square negative 1 cannot lah. So A and B can take form of only positive values, right? Positive and negative real numbers. So if A equals to 4, then B equals to minus 1. If A equals to minus 4, then B equals to 1. Alright, cikgu rasa cikgu stop sampai sini dulu. Ada soalan tak setakat ni? Next class, okay, next class, cikgu ingat sebab esok cikgu dah kena pergi taklimat meeting untuk exam muat tu. Cikgu ingat cikgu nak buat kelas nanti cikgu akan beritahu lah kelas pukul berapa. Tapi esok cikgu akan buat lagi lah kelas cikgu akan naikkan poll lagi sekali. Cikgu tengok sampai pukul berapa boleh habis exam tu. Cikgu akan tanyalah siapa yang berminat untuk join kelas esok. Cikgu, sebab esok kita akan masuk Argand diagram. Okay, Argand diagram dan juga finding modulus and argument untuk polar form. Jadikan complex numbers dalam polar form. So harapnya esok ada lagi lah yang akan join kita dalam kelas online. Alright, kalau tak pun nanti cikgu akan buat recording dan cikgu akan share. Alright. Okay, thank you for attending today's class. I'll see you tomorrow. Okay, masanya belum lagi, cikgu tak tentukan lagi sebab cikgu nak kena tengok taklimat sampai pukul. Alright, okay, thank you. Okay, sama.